Got it.
So tonight's What's Up is, in fact, about what's up. For a member of such a fine astronomy club, I was absolutely terrible at answering this simple question about what star was what star. I turned to my Peterson field guide and found its list of the 21 first magnitude stars. 7 of these are best viewed from southern latitudes, and 4 are the famous stars of summer. But 10 are up in the late March, early April evening sky. In the west, we have Aldebaran and Capella, then in Orion, Rigel and Betelgeuse. Sirius, Procyon, and Pollux fall in a line. Regulus, more or less centered in the southern sky. Arcturus and Spica rising in the east. A little history. Hipparchus and Ptolemy gave us the magnitude scale. First magnitude for the stars that they saw as biggest and brightest. 6th magnitude for the stars they could barely see. In the 1800s, the Herschels got quantitative, initially viewing through different telescope apertures. Norman Pogson standardized the magnitude scale. 100-fold difference in brightness equal to 5 magnitudes, with each magnitude equal to a ratio of 2.5. The Harvard Meridian Photometry program cataloged the magnitudes of 9,000 stars, making visual comparisons using a polarizing prism. The 20th century brought better tools, but for our 10 bright stars, Ptolemy's list really stands up pretty well. If you see a bright star, you know it must be close, or hot, or big, or some combination of the three. The laws of radiation tell us that a star twice as close should be 4 times as bright, twice as hot 16 times as bright, or twice the diameter 4 times as bright. Stars' distance can be measured by parallax, a pretty easy concept to understand, but a pretty difficult measurement. The star's spectrum tells us its temperature. Red class M stars relatively cool, bluish O or B stars really hot. Stellar size until recently was almost entirely impossible to measure. Viewed through conventional telescopes, stars are just dots. Here we have images of our 10 stars, arranged and scaled according to magnitude, from Sirius at -1.5 magnitude down to Regulus at 1.35 magnitude. Sirius is bright because it's hot and close, but Betelgeuse is neither hot nor close. So we know that its rank among these 10 bright stars is due to its enormous size. Astronomers can calculate absolute magnitude because we understand the relationship between distance and brightness. How bright would a star be when viewed from a standard distance of 10 parsecs, which is equal to 32.6 light years? Moving closer to Betelgeuse would increase its magnitude by 6.5, or its brightness by almost 400 times. Moving farther from Sirius would drop its magnitude by about 3, or its brightness by about 15 times. Hertzsprung and Russell plotted the data. Temperature, colors, or spectral class on the x-axis, absolute magnitude or luminosity on the y-axis. The HR diagrams taught us that there were families of stars and led to our understanding of stellar evolution. If we put our 10 stars on an HR diagram, we see that Rigel and Betelgeuse are supergiants. Aldebaran, Arcturus, Pollux, and Capella are giants. Procyon, a subgiant. Sirius is on the main sequence. Regulus and Spica on or rising a little above the main sequence. Now a few facts about each of our stars. Aldebaran, the red eye of Taurus the Bull, has an exoplanet discovered in 2015. Capella, a system of 4 stars. Capella is a system of 4 stars, 2 tightly coupled yellow giants and 2 relatively remote red dwarfs. Our supergiants are in Orion. Stars with masses greater than 10 times the Sun will progress to supergiants and are likely to end their lives as supernova. Rigel is a telescopic binary, the secondary a system of 3 main sequence stars. The distance to Betelgeuse has been difficult to measure. My Peterson guide showed 310 light years. Current measurements with a very large array show log in at 642 light years. Betelgeuse went crazy this year, puffing off a cloud of dust and dimming to a 100-year minimum magnitude of 1.6. If someone asks you when Betelgeuse will explode as a supernova, you can say maybe a few 100 years ago, maybe tomorrow, or perhaps 1,000,000 years ago. The balance of opinion among experts is hundreds of thousands of years from now. Sirius, the brightest star in our sky, has a white dwarf companion. Strangely, Ptolemy recorded that Sirius was red. His catalog is clear, but we don't understand what he was looking at. Procyon, our subgiant, is in Canis Minor. Like Sirius, it has a white dwarf companion, first viewed through the 36-inch Lick refractor. Pollux, an orange giant in Gemini, has a confirmed exoplanet discovered in 2006. Regulus is a system of 4 stars, a spectroscopic binary with A prime likely a white dwarf. There's 2 relatively remote. The BC pair is relatively remote but gravitationally bound and easily separated from Regulus A with a small telescope. Spica is a spectroscopic binary of 2 massive stars, 11 and 7 times the mass of our Sun. Arcturuses and Booties, which I see as an ice cream cone, but maybe that's just me. It's an old red giant from the old disk of our galaxy, just traveling through our neighborhood. These 10 easily observed stars are diverse. They cover most of the HR diagram. Betelgeuse went just crazy this winter. Betelgeuse, Rigel, and Spica A are supernova candidates. We have confirmed planets for Pollux and Aldebaran. Arcturus, an old star, is visiting from the old disk, just passing through our neighborhood, and we have some interesting star systems. Aldebaran, Regulus, and Spica are subject to lunar occultations, but not for about 4 years. So go out on your evening socially distanced walk, look in the sky, and find these 10 stars with all of this in mind, or just go outside and look at the bright, beautiful stars. Thank you.
Thanks, Chuck. Now, if people want to ask any questions, feel free to go ahead and go into the chat and ask any questions of Chuck.
Yeah, the four-star systems are Capella and Regulus. The question on orbits, is that the planets or is that the stars? For the stars on Capella, I think both Capella and Regulus, the close coupled stars orbit very quickly, with the remote stars less so.
Well, if there are no more questions, what I'm going to do is give us a 5-minute break or so.
Okay, there's one more question there, and I think on which are interesting telescopically, and I think all the binaries, Regulus very easy, Rigel a little difficult, the red dwarfs for Capella can be found and conceivably even separated. Sirius, I've read that double can be viewed with a small scope with extreme care, and after that they get pretty difficult.
And small scope being 16 inches or bigger. That's what sky telescopes. Okay, why don't we go ahead and take a 5-minute break. Enjoy your virtual snacks. We are going to resume with our main speaker in just a few minutes. Okay, we are going to start our main speaker. Normally, it would be my pleasure to have Dick Flask come up and introduce our speaker, but normal doesn't seem to be the normal these days. We would like to introduce our main speaker, Benjamin Burress, the Shabo Space and Science Center staff astronomer. After earning degrees in physics and astronomy at Sonoma State, he's held positions as a teacher in Cameroon with the Peace Corps. That's interesting. Lead observer at the Cooper Airborne Observatory at Ames Research Center, and head observer at the Lowell Observatory in Flagstaff. It's my pleasure to introduce Ben Burress, then and now.
Good evening, everyone. Oop, my hair just got messed up. I want to thank you for having me as your guinea pig for your first virtual general meeting. I assume that you can see the opening slide. I'm sorry, I'm new at Zoom, so I'm not sure what you're seeing. I'm hoping you're seeing my full screen PowerPoint.
No, we're seeing the speaker's screen. If you can share your other monitor.
Well, I only have one monitor. Let's see here.
Yeah.
What
Okay.
do we
Well,
have?
go into the presentation and we'll see what happens.
Well, let me try resharing here. And share. Can you tell me what you see now?
Yeah. See the full screen now.
Okay, so you see my opening slide. Great. Well, thanks. On behalf of our director, Adam Tobin, I want to thank you for inviting Shabo to present to you tonight. Fair warning, I started out this presentation with 30 slides. I won't take too much time with them, but having a lot more time on my hands than I expected to keep tweaking the presentation. It's actually up to 40 now, but don't let that scare you away. I'll try to breeze through some of these slides more quickly. And so let us just begin. Chabot Observatory, Oakland Observatory, all the different names the observatory has gone by over its last 137 years and 3 locations, well, has a very long and interesting history. So a good portion of this presentation will be about that history. I've dug up some nice old pictures from the past century and the century before that. And I'll try to tell you the story of Chabot and interesting people and the different telescopes and their histories as we go in 40 words or less. Well, let's go here. So there we go. It's working. Great. Let's start at the beginning. The inspiration for the observatory in Oakland came from the superintendent of Oakland Public Schools at the time, Jewett Gilson. As the story goes, he was visiting Philadelphia, and there was a school for boys in Philadelphia that he visited that had its own rooftop observatory. So if you're seeing my presentation here, you're seeing a drawing, a painting of that school for boys and its observatory dome on the top. But Gilson apparently saw that and said, Oakland has to have that. So he went looking for somebody to pay for it. For an observatory for Oakland. Brings us to Anthony Chabot. So Anthony Chabot wasn't an astronomer, and I don't even believe he was telling me my internet connection is unstable. Hopefully you can. Anyway, Chabot was not an amateur astronomer or astronomer. He was a water engineer. He came from Canada, St. Hyacinthe, Quebec, and he got his start in California during the gold rush. Let's move on to the next slide. There's a nice historical photo of part of Lake Merritt in Oakland. This is the southwest corner where the estuary feeds into the lake from, or the channel feeds into the lake from the estuary. The house on the point there is Anthony Chabot's house, the one he was living in when he passed away. But Chabot, as I said, he developed gold mining hydraulic nozzles, the gold mining nozzles that laid waste to places in the Sierras and washed all sorts of toxic chemicals down the streams in San Francisco. That was kind of his dubious. He kind of gave up on gold mining. He came down to the Bay Area and began building water systems, drinkable water, not contaminated water, including San Francisco, San Jose, Vallejo, and the East Bay, including Temescal and the now Lake Shabo, originally called the San Leandro Reservoir, and then later the lower San Leandro Reservoir, because there's an upper one now. Some other highlights of his distinguished career: he was the first president of the Oakland Gaslight Company, company that generated gas for heating and for street lamps before there was electric light in the city. And also, as the story goes, I was reading an article that said on his deathbed, practically, he drafted up a new will and added to it a bequest for the building of the Oakland Women's Home. There's a home for women, working women, mothers, unmarried, for whatever reason, to support them. So that was sort of his dying bequest. But of course, the bequest, or the philanthropy that we're interested in, is this thing. So the original Oakland Observatory, here's a nice picture of it being constructed. You can see the tall main telescope tower and pier. You can still see the pier inside the woodwork there on the right. The lower structure to the left was for the Meridian Transit Telescope, both instruments of which are still at Shabo, but they were the original instruments of the original observatory. And here's a longer view. If you look around in there, you may be able to spot the original Oakland Observatory building. See it yet? I don't know if you can see my mouse, probably not. It's in the center left section. You can see this tall tower. It looks like a water tower. Here's a shot from the south, looking up onto the square, Lafayette Square, still called Lafayette Square, actually, and the original observatory building. It was originally named the Oakland Observatory because apparently Anthony Shabo, he's a fairly humble person from what I've been able to gather. He didn't want it named after him, but following his death in 1888, the public wanted it named Chabot Observatory. So after he died, they went ahead and named it Chabot Observatory. Also had a nickname, the mucilage bottle, apparently. But interesting old building. The dome was a 14-foot chamber and housed the original 8-inch refractor, which was later named Leah. So to give you a little perspective on where this is and where you can still go and actually see the original grounds of the observatory, the first observatory, Lafayette Square is in downtown Oakland. It's right where the yellow arrow is pointing. There's a Google Earth view on the left showing the park. The whole square that the observatory is built on is a big park. There's no original building there. That was torn down a long time ago. But you will notice a feature if you look in there, a big grassy circle. I'll give you a little side view to look at here. These are Google Earth street views. You can go enjoy it through Google Earth too. That lawn is actually not just a circle, it's a dome. So there's a dome-shaped lawn. They actually shaped into a nice convex dome, which marks the original site of the original observatory tower. Now, when we went down there on our 125th anniversary, we were planning a big celebration. It was the Olympics year, so we did a giant Olympics run from the original site all the way up to the new site, passing by the second site as well. We actually had Olympian athletes running with us and turned it into a big relay event. But when we got down there to do the planning, we found there was absolutely no commemoration of the spot. There's nothing saying this is where Chabot Observatory had been. So we changed that. We created some ceramic tiles that mark this spot as the original Chabot Observatory location. And people-wise, Charles Berkhalter, initially he wasn't the director of the observatory. There were other city officials who were officially directors. But he was hired in 1883, 1885, I think, to be, well, to run the observatory along with a couple of other people. But he had experience with telescopes, and they hired him to operate the telescopes and to present to people and students of Oakland. In Anthony Chabot's donation of the money that built this observatory and bought the original telescope, he stipulated that the observatory would be forever and always open for free to the public and the students. And that's a tradition that goes on to this day. All the telescopes at Chabot can be accessed for free on our Friday and Saturday nights. Anyway, Berkhalter is thought to have been one of the first amateur astronomers in Oakland. He originally had a 4-inch refractor. I think that's what he's standing next to in this picture. But he also had and built in his backyard his own observatory. So this is a picture from inside his backyard observatory, which has a 10-inch Newtonian reflector that he purchased. And so that really makes Chabot Observatory the second observatory in Oakland. His was the first. And he was an avid amateur astronomer. I love this picture. I kind of picked this slide just to show this picture. He was present at one of the 1800s Venus transits at Lick Observatory. He went and joined that crew. This picture, we're not sure which of the two transits in that century this was, but it was one of them, obviously. We believe that Charles Berkhalter is the one on the left, standing next to the camera. At least none of the other people in here fit that bill. So that is our story, and we're sticking with it. There we go. So the original Chabot Observatory had its 8-inch Alden Clark refractor, Leah, named Leah. It served about 10 to 12 visitors, public, per night. It was open 3 nights a week to the public in general, and then a couple of nights a week to school students. And then Friday was for actual work with the main 8-inch telescope and the 4 1/8-inch transit instrument, which is used to calculate and set the official time. So that time was used not only to ring a bell at City Hall through an electronic bell ringer twice a day, but the navigators who came into the Port of Oakland came in to set their chronometers to the observatory's clocks. And also the western terminus of the Central Pacific Railway used the time as well. Railways need to know accurate time, so obviously. Now, one of Berkhalter's more famous legacies is his passion for traveling the world to photograph solar eclipses. So this is a scan you're looking at of one of his solar eclipse pictures, right from a glass plate. We still have the original glass plates, positives and negatives, up at Chabot. But he was so interested in solar eclipses, he traveled the world, starting in Cloverdale. It was the 1889 total solar eclipse. He was actually put in charge of a small expedition to go to Cloverdale. That's not world travel at this point, but that came later. In 1896, he was part of a group from Lick Observatory to go to Japan to observe an eclipse. Unfortunately, that one was clouded out, but he got a lot of good pictures of Japan in the meantime. He went to Jur, India in the 1898 total solar eclipse. Apparently that was quite an epic voyage. He had to go by ocean across the Pacific, I believe. But I guess there were like bandits in the woods, and there was a plague going on over in the south or something. So there were a lot of perilous things going on when he was trying to get these pictures. And then most recently in his expeditions, he went to Siloam, Georgia for the 1900 solar eclipse. Now, I believe it was at this one that he refined and perfected a photographic technique for photographing specifically total solar eclipses. There's a picture of the side of his solar eclipse camera here with all its electronics and gadgetry. On the left, you'll notice this is a scan of one of his glass plates from Georgia. Right in the middle of the sun, you'll see a hole. That's actually a physical hole in the glass plate that an axle stuck up through, a cam. And on that cam was mounted probably paper, I believe, or at least they plotted on paper, a mask that was shaped in just the right way to control the exposure of the eclipse radially outward. What he was trying to do was get in one picture, details of the eclipse close to the photosphere, the surface of the sun, and all the way out into the corona. Of course, the problem is the contrast and brightness is so great, it was difficult to get one picture that showed all those details. But by controlling the exposure with this rotating mask, shaped just properly to limit exposure of the brighter parts of the sun's disk and the corona, he got some of the best, I think touted the best solar eclipse pictures at the time in the world. Coming back to Oakland a little bit here, we're about to leave the first Oakland observatory, Chabot Observatory, but I wanted to show it was upgraded in 1892. There were public classrooms added, a workshop, a very useful workshop, said Berkhalter. The 8-inch dome was rebuilt into a 20-foot diameter building. And then they had a reception room. So here's scans of postcards at the time, hand color painted postcards of the observatory on Lafayette Square. Won't linger too long there, but I liked those postcards, so I threw them in there. So at the end of the Lafayette Square observatory era came due to the electric light. So up until some point in the early 1900s, the streets of Oakland were lit by gas lamps. Not a big problem as far as light pollution went, but when the electric light was starting to spread out in Oakland and started to put light pollution into the sky, that became an issue for this downtown observatory and telescope. And on the right, you'll see a picture of City Hall, and I've labeled it the infamous beacon on City Hall. This is actually what Charles Berkhalter said. It was infamous to him, he said, this bright beacon on top of the City Hall that shined right down onto the observatory. And so at this point, they started looking for another site to relocate the observatory to. The site they settled upon, they actually checked out several sites in the Oakland Hills, but the site they settled upon, there's a picture on the left of an old farm, the old Landry farm, from what I've been able to pick up. This is the area, this is the property that was bought to build the observatory on the hill, probably the hill behind it, I believe. The trees are all different now, so it's kind of hard to tell. But they had wanted to put the observatory higher up in the hills, where you should put an observatory, right? But there were problems with that. Even back then, getting up into the ridgeline of the Oakland Hills was not easy for the residents of Oakland. They didn't have the infrastructure we have today. But down at the base of the hills, protected in this little valley by some surrounding hills, shielded by light and wind, is shielded from light and wind, was this little hill that they finally chose. It had the added benefit of being close to an electric trolley line that made it much easier for the public and the students to make it to the observatory. So here's a couple of shots of the second Chabot Observatory. On the left, probably earlier, the 1915 was when the relocation happened and the building began. But you can see the two domes in there, the smaller one, of course, to house Leah, the 8-inch refractor that was originally purchased by Shabo, and then the larger dome for the planned acquisition, or an acquisition that was going on at the time, of the 20-inch refractor Rachel. So here we have a couple of pictures. The telescope Rachel, which you can come up to Shabo and look through even today, of course, was originally on display in San Francisco at the Panama Pacific International Exposition in 1915. It was the Warner and Swayze company had built it, and they were displaying it along with other optical instruments at that exposition. The exposition took place around the Marina District. It was quite a huge city of structures for this exposition, most of which were torn down in the years after. But the old Palace of the Fine Arts building with the Exploratorium was in until a few years ago is the only remaining structure from that exposition. Anyway, there's the picture of the 20-inch telescope with Charles Berkhalter standing down there at the base. On the right is the 20-inch at the Chabot Observatory after it was installed on Mountain Boulevard, the second location. I threw that one in. This was a scan I made of an old glass lantern slide from the time. I believe these pictures may have been taken by Rachel, the 20-inch. Just threw them in there because Saturn is actually my favorite object to look at through those telescopes. This is just a picture of Berkhalter on the left. This is around the 1915 era. John Brashear in the middle, he was the lens crafter, and then Ambrose Swayze, the Warner and Swayze company. The story behind Rachel's arrival, that's not what I wanted to show. I wanted to go back one really quickly here. Very quickly, the telescope itself was purchased from Warner and Swayze. The 20-inch lens blank was imported from Schott Optical Works in Jena, Germany. This was around the beginning, or close to the beginning of World War I. And there's this whole drama about how they had to obtain special permission from the German government at the time to export it from the company, just as the British naval blockades were coming up and blocking off commerce. So it escaped from Germany just in time to finally make its way to Oakland, where when it arrived, it was thrown into a bank vault until John Brashear could carve it. So that's the story. So Charles Berkhalter, he was the director of the observatory until he passed away. He tried to retire 3 times, and his request was denied every time. Today I wonder why. If he put in all this work and he wanted to retire, why wouldn't they let him? I guess he was just that good. But he died in 1923 following a wildfire that threatened the old observatory. And some say it might have been stress from the fire that contributed to his death. But as the story goes, on his deathbed, he handed the keys to one Earl Linsley, who became the second director of Chabot Observatory, and told him something to the effect of never give them up, never give the keys up. So Earl Linsley, I'll start a new era here, starting in 1923. He was a geography professor teaching at Mills College. If you know the Oakland area, you'll know that Mills College is right next to the previous Chabot Observatory, the one where Rachel was initially installed. But he was an educator, and apparently he kept doing his day job of teaching at Mills while also being the director of Chabot Observatory at night. People asked him, when do you sleep? And he took an hour cat nap on the hammock on the porch now and again, but I guess he worked 24/7 or something, but he was quite an educator. So he brought lots of people together to teach them about astronomy and other science topics. The next year, after he became director, he formed what is now the East Bay Astronomical Society. It was the East Bay Amateur Astronomical Association at the time. So he had put out a call to all people who were interested about science, astronomy in particular, to gather them together and start a club, basically. There's an early picture, I believe, of the original association members sometime in that era. And one little side story, just thought I'd mention it because it's of astronomical interest. In 1938, the largest meteorite ever recovered in California was discovered by 3 hunters who were hunting up in the Modoc area of northeastern California. One of them, Clarence Schmidt, you can see on the right, that's a picture of Schmidt over there, had apparently attended one of Earl Linsley's lectures on meteorites, interestingly. And when he saw this giant chunk of iron and hit it with a hammer, he said it rang like a bell. He suspected it was a meteorite. So he went and reported this. And then there followed this big Indiana Jones-like intrigue of different people trying to get the meteorite for their own and posing as Smithsonian officials and whatnot. But ultimately, the government decided that it found on federal land, so technically it was supposed to go to the Smithsonian, which it did. But the story goes that the Smithsonian, or the government, sent Earl Inslee to go over this meteorite. So he was led back by Clarence Schmidt to recover this 2,573-pound nickel iron meteorite. Again, this is the Goose Lake meteorite, largest meteorite recovered in California. As soon as it got back to Shabo, and here's a picture of them unloading it or loading it back onto the truck, Earl Linsley put it on display on Treasure Island in the 1939-1940 Golden Gate International Exposition. After that, the Smithsonian said, ship it back to the Smithsonian National Museum, which he had to, but not before making a plaster cast. He made a cast of the entire meteorite, which we still have up at Shabo. So you can come up and get a good sense for the size and shape and appearance of this meteorite find. So Earl Linsley was director until about 1947. During this time, a lot of the volunteer work, especially the East Bay Astronomical Society and whatever they were named prior to that, pitched in a lot and did a lot of work for the observatory. Eventually, they hired Kingsley Whiteman. We'll get to him in a moment. Actually, that's a picture of him on the left addressing a class in a new building that they acquired in 1964. It was a classroom, some offices and workspaces, and a planetarium up on top. So in 1964, this was funded by 4 local Rotary clubs. And this is the building I remember, along with the telescopes when I would go there in the 1960s. As a child, I was taken there by my family on the Friday nights they were open to marvel at the planetarium and the sights through the telescopes. Just a couple of other highlights. A lot of things happened at Shabo over the years. Operation Moonwatch was one of these amateur observation opportunities. Came about the time Sputnik, the Soviet Sputnik satellite, was orbiting the Earth. They had set up this system where lines of observers would use these simple little telescopes and scan the meridian above and wait for Sputnik to fly over so they could actually make measurements of its orbit. That is, use the optical sightings through these telescopes to get an idea for Sputnik's orbit and satellites that went up afterwards. Chabot Observatory was also part of optical tracking network that NASA ran around the Apollo program. So NASA was interested in getting secondary observational information on the Apollo flights and some of the events. So there were a number of things for small observatories like Chabot to observe during the Apollo flights, not just the trajectories of the spacecraft as they went to and from the moon, but also things like when the rocket booster panels that connected the command module and housed the lunar module would fly off into space, get jettisoned, they would look for the light blooms from those. They would also look for the light blooms caused by urine dumps from the command module, when they would blast urine out into space, and it would dissipate in a freezing cloud of tiny droplets. They would be able to observe that. And one story we like to tell at Chabot is how Chabot Observatory may have saved the Apollo 13 crew, or at least helped to save them. So this was during the Apollo 13 intrigue, when, if you remember the whole story, they were on their way back to Earth, but NASA needed to get their exact trajectory so that they knew, how they were going to alter their course so they wouldn't either bounce off the atmosphere or burn up in the atmosphere. They had to know exactly as they were coming in, the angle, because the instruments on the Apollo 13 were compromised to some extent. So the NASA apparently sent out word to all its optical tracking network observatories to get position measurements of Apollo 13 as it was coming back to Earth. And as the story goes, only Chabot Observatory had clear skies at the time. So the phone rang, and the crew at Shabo, the volunteers who were operating the telescopes, took the call and got the measurements and sent them back to NASA, and then the fog came in, not too long after that. So that's the story we like. We say we saved Apollo 13, but at least, gave NASA more information. So I mentioned Kingsley Whiteman. This is him later. You can kind of date this picture if you look at the posters on the wall on the right-hand side. There's some Star Wars pictures over there. So this picture was probably taken in the very earliest. It was the late 1970s, probably the early 1980s. But this is the Kingsley Whiteman I remember. He was a great teacher, great public speaker. He was dedicated to the observatory and taught generations of kids like me. It's just another shot of the old Shabo at night. Didn't have any nighttime pictures of the observatories here. So here's one. So the second observatory also came to an end. This time it was not moved by light, but by Earth. So the second observatory, which is on Mountain Boulevard in Oakland, sits right on the Hayward earthquake fault. And there came a point where, because the buildings were not earthquake retrofitted, there came a point where they could no longer let school groups come inside the buildings. They could still have, individual public citizens come in under their own risk. But if there was going to be a major earthquake along the Hayward Fault, that could cause considerable damage to the observatory. So there was a lot of talk about what to do, either retrofit the old, or rebuild the old, or relocate again. And relocation was eventually what was decided upon. If you look on the map on the right, the present Shabo, that's meaning the second one down on Mountain Boulevard. And at the top of that map, you'll see a couple of rectangles, 1 and 2. Those were 2 sites in Joaquin Miller Park on the ridgeline of Oakland that were considered for relocating the observatory. They ended up picking number 1. Interestingly, when in 1915, they were looking for sites for the relocation back then, this was actually one of the sites, Redwood Peak, which is not, it's a stone's throw from the present Shabo Observatory, was one of the locations they considered for relocation in 1915, but it was too remote. People wouldn't be able to get to it. People still think it's too remote, even though it's a really easy drive up the Oakland Hills. So here we are today. Best location for an observatory in Oakland. We're right on the ridgeline. We're so close to the highest point that part of the ridge that our elevator shaft on the west building is actually a little higher than the peak. Redwood Peak itself technically is not in Oakland, it's in Contra Costa County. We straddle the line between counties right along the ridge there. But we're up high. On a rare night when there's fog down low, city lights can get blacked out, which is wonderful. And just for informational purposes, our Joint Powers Agency, JPA board, consists of members from the City of Oakland, the Oakland Unified School District, East Bay Regional Parks, and there is representation by the East Bay Astronomical Society as well. So I'm going to give you, I'm getting kind of toward the end here. We're at the new Shabo, so I have several pages just to show you the kinds of facilities and programs that we do at Shabo. Not at this moment. We are shut down, of course, along with all the other museums and science centers. Don't know when we're going to reopen. That remains to be seen. We'll, we'll hope it's not too long. Anyway, the new building is quite a bit bigger than its predecessors. It features, of course, the two historic telescopes, Leah and Rachel, which you can see in their new domes. These are really clean shots that were taken 20 years ago when they were first relocated up here, when the domes were still shiny and the floors looked really clean. It still looks wonderful up there. These are beautiful old telescopes, beautiful old instruments, and people can still come up and look through even Leah, 137-year-old telescope. We have a 70-foot diameter planetarium with multiple systems in it, including the original Zeiss Mark 8 projector, star projector, a full dome digital system, a laser music system as well. So there's a number of types of things we do in the planetarium, not just star shows, but full dome shows, concerts, weddings. The planetarium is used for a lot of things. We have a theater. It was originally a 70mm film theater with a big wraparound fisheye projector lens. Unfortunately, they stopped making movies in that 70mm format not too long after we opened. So there weren't very many films we could show in there, but we used the theater for a lot of presentations, guest speakers, live science demos, and standard video projection as well. We have 6 classrooms, and we have a Challenger Learning Center. The lower left picture you're looking at there shows some kids in our spacecraft simulator. With the Challenger Learning Center is a simulation of a mission control and a spacecraft, and groups get together and through teamwork solve space missions like a trip to Mars or investigating a comet. And there's assignments for each participant and task cards and problems and plot complications like carbon dioxide levels are on the rise, what do you do? So the teams have to figure out things like that. It's very engaging though. And of course, we still have wonderful nighttime observatory programs, not only with our historic Leah and Rachel, the 8-inch and 20-inch telescopes, but the vintage 2003 Nellie, a 36-inch reflecting telescope, which you can see in the middle there. That is used for public observation, for scouting groups, for private events, and for some astronomical work. We have volunteers who come in and do near-Earth object tracking asteroids that come close to the Earth. In the past, we've had exoplanet observations done from here and a lot of astrophotography. Daytime events in the lower left-hand corner, whenever there's an eclipse during the day or a transit of Mercury or Venus when it happened, we can get huge crowds up on the deck. And we just built out a new outdoor observation deck expansion that features observing nature in general, all sorts of activities and outdoor exhibits focused on the idea of observation of nature, not just the sky, but things on the Earth as well. The lower right-hand corner picture, you can see the back of Kingsley Whiteman's head. So he was wheelchair bound, but after Nellie, the 36-inch reflector was dedicated, he was brought up and given a party, basically. And over the years, we've had a number of guest speakers and luminaries come to Shabo. Albert Einstein, not in person, although Einstein did visit the previous Chabot Observatory early in the 20th, sometime in the 20th century. But he was giving a commencement speech at USC, and he was touring the West Coast, and he came by Chabot. So Albert Einstein has looked through at least Rachel, maybe through Leah as well. So if you come and look through our telescopes, think of that. But we did get a nice presentation by his accountant's niece, which was really wonderful because she had a lot of firsthand stories about Albert Einstein. But lots of famous people have come up, and they continue to, and hopefully will continue to after we reopen, after all the coronavirus stuff has passed. We have school programs. We serve about 40,000 school kids per year who come up to do pretty much full day classes, field trips. We give them science classes, they explore the exhibits, and we give them shows in the planetarium, among other things. We have done more in the past than these days, but teacher professional development workshops. So we bring teachers up to learn about teaching science to their kids. Summer camps. We've been doing summer camps practically since we opened 20 years ago. So they come in and they do Challenger camps and space camps, and we've had a wide range of different themes for our summer camps. We do outreach. We have a portable planetarium, although right now we need to get a new lens for the projector. It broke and we're looking for a replacement, but we had in the past taken the planetarium out in the community. And we have a thriving volunteer corps, about 150 active adult volunteers right now, and some of them have been around Shabo since we opened 20 years ago. Exhibit explaining, learning how to operate the telescopes for day and night observation, and many other activities. Oh, I should mention Telescope Makers Workshop. It's run by volunteers at the East Bay Astronomical Society. That's actually been operating since about 1930, either at Chabot Observatory or in someone's garage. But since we opened, it's been run out of one of the classrooms up at Chabot Space and Science Center. But anyone who wants to come in and learn how to make a telescope will be shown how to do so, given about maybe 40 hours of personal labor. They can end up with a very high quality, if they put the work into it, telescope. But that continues, and it's a wonderful offering. One story I heard was one of the graduates of the Telescope Makers Workshop later was employed at Shabo. He was a mechanical engineer, Kevin Medlock. He designed Nellie, the 36-inch telescope, and he had it constructed. Another alumna of the Telescope Makers Workshop went on to work on one of the major principal camera instruments on, I believe it's the Mars Reconnaissance Orbiter, orbiting Mars. So there's been some getting out into the real world there, real science, for sure. Okay, back to our volunteers. Our volunteers have a very strict dress code. No, not like this. This was a volunteer appreciation event we did during or around one of the Oscar nights. So we turned it into an Oscar night of our own with a red carpet and everything. But we also have teen volunteers, our Galaxy Explorer program. They are high school students who come up, and we have 160 of these right now. They develop their own science demonstrations to give to public visitors. They present them, obviously. They support special events at Shabo. They do outreach. They have formed their own teams. The astronomy team will be out every Friday night with their own telescope that they refurbished, a 16-inch reflector called Maya. And there's an engineering team, planetarium team, and there has been media team in the past as well. Last I heard, we had a success rate of 100% of the Galaxy Explorers going on to college, which is very cool. We also have a younger middle school program called the Champions of Science. They come in mostly to get science enrichment, but it's also a feeder for the Galaxy Explorer program. So here's some shots of Galaxy Explorers doing their science demos. And here's some shots of some of the Galaxy Explorer special interest teams. Every year, for a few years, we were doing an open house for them. So those are pictures taken at open house where the teams would show off their stuff and things they did in their team for the year. And this is about my last slide. I had to change this since I originally wrote it. I was going to give you some upcoming special events at Shabo. The next First Friday was going to be on April 3rd, but we'll still be closed at that point, I'm sure. But every first Friday of the month for the past 3 years, we've been running special evenings of themed events. So the whole center closes at 5 as usual, but then reopens at 6 until about 10 o'clock. Telescope observing starts around 7:30 as well. But we've attracted a lot of people up to First Friday events. Each month is a different theme, and there's sometimes live music, special speakers, bars, you name it. It's a fun event. Tinkerfest is currently scheduled for May 9th. It's an annual thing we've been doing. People can come in and take things apart and build things and tinker around with stuff. And we bring in community partners and other people to demonstrate their stuff, and artists and industrialists and scientists and whatnot. Don't know if the May 9th one will go as planned. We'll see. We'll see how things go. And hopefully in August, when Shabo Space and Science Center, the current Shabo, will be celebrating our 20th anniversary at this current site, we'll have a celebration sometime in August. But again, there's a lot of TBDs going around right now. First Glance is a monthly thing. It's the members telescope viewing. So we have special members only telescope viewing every month. But again, when that next one will be, we'll see. And then of course, weekly telescope viewing, which is shut down right now, along with everything else. In this case, it's weather and coronavirus willing. So I don't know how much time I just consumed because I don't have a clock next to me, but that was my last slide. I am going to see if I can bring up my chat window here, because I have not seen my chat window. There it is. I hope this whole 45 minutes to an hour that I've been talking, people have actually heard me. It's a little weird to be giving a presentation without seeing or hearing the people you're presenting to. You're kind of wondering, well, did my internet just crash and I've been talking to myself for the last half hour? But oh, it looks like I'm seeing things now. You're welcome. Thank you very much again for having me present to you, and I will certainly entertain any questions you might have that I can answer. Thank you.
Can you tell us how the telescopes were named, Rachel, Leah, etc.?
Sure. Rachel and Leah, the 8-inch and the 20-inch, were named by Charles Berkhalter, and they're from a story in the Bible. I believe it's Jacob's daughters are Rachel and Leah, Leah being the older one. Or maybe it's Jacob who wants to marry, okay, it's not the daughters. He wants to marry Rachel, the younger daughter. But the father of the girls says, no, you have to work for me. You have to marry Leah, the older one. Work for me for 7 years, and then I'll let you marry Rachel as well, I guess. So Jacob had to wait all those years before he could actually marry Rachel. So Charles Berkhalter had the 8-inch telescope, which was a fine instrument, but for many years he wanted to get a larger, better, younger telescope, the 20-inch Rachel, but he had to wait for the funding to purchase it. So that's how those two got their names. The third telescope, the 36-inch reflector, nobody's asked, but oh, somebody has asked, is named Nellie. The story I heard was that this is the granddaughter's name of the donors, Merrill and Lillian Martin, who gave about $500,000 for the construction of the building and the telescope. The mirror blank was actually donated by Lawrence Livermore Lab, but I believe Nellie was the granddaughter of them. I also learned through reading that one of Anthony Chabot's relatives, a niece, I believe, I have to go back and read that, was also named Nellie, interestingly. Thank you.
Anyone else have any further questions? Type them in or ask directly. Thought you did an excellent job speaking to a computer screen. It's a little odd, but that's all right.
Thank you. Yeah. It's yeah, like I said, it's kind of weird not knowing for sure if people are listening. Somebody said that you might have to have a field trip to come up to Chabot. I hope you do. If you do that, maybe you want to target a first Friday. If you have some time to spend, and if you want to do as much as possible, maybe you could come up in the afternoon on a first Friday and stay through the first Friday evening event. And that'll give you everything: day exposure to our exhibits and our shows, the first Friday festivities, and then you can always walk out and do telescope viewing as well, if it's a clear night, of course, and there's no coronavirus around.
Anybody else? Any other questions? Comments?
Oh, I see a question from somebody. How did Shabo acquire the land in the hills? I'm assuming the current location. So the current location, we are mostly in the upper section of Joaquin Miller Park. So technically, it's City of Oakland parkland that we are on. Since City of Oakland is one of our JPA partners or board agents, I guess, I don't know exactly what the title ownership of the land is. I think it's probably still City of Oakland. I know the two telescopes, Leah and Rachel, are technically the property of the City of Oakland as well, and always have been historically. So I don't know if our land is leased or long-term leased, or if it's just, City of Oakland parkland, and we're a City of Oakland nonprofit education. How can you best support our work going forward? Well, you can become members. You can come up to Shabo. You can become a donor, perhaps. Come to our gala, which usually happens in October each year. They're always a lot of fun and usually held right there at Shabo. Is the planetarium working? Not at the moment because the whole place is shut down, but otherwise, yes, it is. So, as I mentioned in the presentation, we have the Zeiss projector, which right now is being operated and run, given shows by members of the East Bay Astronomical Society. They brought it back to life, refurbished it, and they do shows primarily on first Friday evenings. They do a Sky Tonight show. They also come in and do special shows for private groups like scouting groups and overnights, sometimes a wedding. The full dome digital system, which we just got an upgrade for the computers that run it, the full dome digital theater, and we've been refurbishing the projectors, is running very well. So yeah, the planetarium is working once we open up again. So let's see, for the portable planetarium, I'm being asked, have we considered a convex mirror projection system? Yeah, very expensive. Well, what we have is it's a fisheye lens projector system on about a 20-foot diameter inflatable dome. Unfortunately, the lens, which is of course a crucial part of that system, was dropped, not by me, I won't say who, and it broke. And I've been trying to find a replacement for it, but they haven't made them in a number of years. So we're trying other lenses and other ways, but at this point, if we can't get a lens, maybe a wholesale replacement of the projector and its lens will be something we have to explore. Oh, very inexpensive, sorry. Potentially, yeah, we are exploring ways to repair, fix, or replace the parts for the portable planetarium. Hopefully, we'll get that working again. how close is the nearest earthquake fault to the current Chabot? The nearest one I know of is the Hayward Fault. And it's, as the bird flies, it's about a mile, mile and a half down the hill. Now, that's still pretty close. It's a lot farther than the previous Chabot Observatory, which was pretty much right on the fault line. So if you drive on Highway 13, the very south end of 13, where it meets with 580, is where you'll find the previous Chabot building. You'll still see the domes up there as well, the buildings. That whole corridor through which 13 runs, and 580 continuing south, is a valley, right? It's a V-shaped valley. It was formed because of the Hayward Fault. So the freeway is built along places where it was easy to build a freeway, but the current building was designed to withstand up to a magnitude 8 earthquake. So it's still fairly close to the Hayward Fault, but at least it has the structure that hopefully will keep it from collapsing. Let's see here. Okay, I'm just getting more advice on a first surface projection mirror. Thank you. I'll do that. Paul Bork's website. I don't know if I missed any questions going by here. Say more about our reliance on donor support. I don't know the breakdown of the numbers. I'm not on the finance side, but I know we do rely pretty heavily on donors. We get government money, city money. I don't think we get any state funding, but we on occasion get some federal money. We have also received grants for specific programs over the years, a lot of them from NASA or the NSF. But yeah, the revenue stream for Shabo comes from a lot of directions, including, of course, gate ticket sales. A lot of money comes in for facility rentals. We actually make quite a good amount of money just renting spaces of the facilities to private events, everything from weddings to conferences to meeting spaces and other types of offerings. So the revenue stream is diverse. It's never enough from what I hear, but that's my answer anyway. You're welcome.
Well, not seeing a whole lot more questions. Why don't we call this? Thanks, Ben. That was a very informative meeting.
My pleasure. Thank you for having me. Thank you very much.
And I will send out a email with the location of the recording. Thank you all. I'm going to end the Zoom meeting right now. Thank you.
Thank you. Good night, everyone.
Good night. Oh,